Hi all. Welcome to Java Application Deployment on the on-prem Kubernetes demo. In this video, we are going to demonstrate the deployment of Java applications on the on-prem Kubernetes cluster. The complete process is orchestrated through the Jenkins pipeline. The tools, which are used in this Java application deployment are GitLab, for source code management, Jenkins, for continuous integration, SonarQube, for code quality checks, JFrog, for Artifactory management, and Docker image registry. Kubernetes, for container orchestration. Docker, for containerization. Let's explore the workflow of Java application deployment, stage by stage. Jenkins job will pull the Java application source code from GitLab. A webhook is configured on GitLab, so that the ongoing deployment job will trigger automatically when a commit happens on a particular branch. In the next stage, the Java application source code will be built, either in Jenkins master or slaves. In case any failures in the build step, pipeline will be aborted. The deployment package will be archived on Jenkins for future use. In this next stage, Jenkins uses the SonarQube scanner plugin for continuous inspection of code quality to perform automatic reviews with static analysis of code to detect bugs, code smells, and security vulnerabilities. SonarQube offers reports on duplicated code, coding standards, unit tests, code coverage, code complexity, comments, bugs, and security vulnerabilities. When the code doesn't meet the quality standards, an alert mail will be triggered to the development team, and the pipeline will be aborted. Once the code meets the quality standard, the archived Java application package will be pushed to the JFrog Artifactory repository. The Docker image will be built and pushed to the JFrog container registry. In the final stage, Jenkins will deploy the application using the Kubernetes and deployment YAML from Git, which will perform the below tasks. Create a deployment on the on-prem Kubernetes, which will create a replica set, which in turn create the pods using images from the JFrog container registry. The Java deployment will be exposed as an external service, which in turn uses MetalPound to provision a layer 4 load balancer and expose the application on the predefined IP address. Now, let us see how the continuous integration and continuous deployment of the Java application happen via the Jenkins pipeline. Let us trigger the Jenkins pipeline for Java application deployment. In the first stage, the Jenkins pipeline job is preparing the servers and Git config. In the next stage, the Jenkins pipeline job is pulling the source code from GitLab, which contains the Java application source code, Docker file, and Kubernetes. In the next stage, the Jenkins pipeline job will build the Java source code, either in Jenkins master or slaves, based on the target operating system. In the next stage, SonarQube analysis is getting executed, and it is validated against the quality gate. As the quality gate is passed, the Jenkins pipeline is pushing the build binary package to JFrog Artifactory, then the Docker image with Helm will be built using Docker file, and pushed to the JFrog container registry. In the final stage of deployment, the Jenkins pipeline job will deploy the container, and expose the application via MetalPound load balancer, on the on-prem Kubernetes cluster using the Kubernetes plugin, and deployment from Git. Now, the deployment has been completed. Let us check the load balancer IP address for the application. We can access this load balancer IP address in the browser, and this is the Java application that was deployed on the on-prem Kubernetes cluster. This is the complete workflow Java application deployment on the Kubernetes. For more information, please browse www.zippyops.com. Please follow us on social media, links are available in the description. Like, share, and comment on this video. Subscribe to our channel for the latest happenings on DevOps. Thank you for watching this video.